Welcome to even and odd Fourier series examples. So recall that if f is even, then the Fourier series on negative LL is a cosine series, capital F of x, is equal to a naught plus the sum from n equals 1 to infinity of a sub n times cosine n pi over Lx, where a naught is equal to 1 over L times the integral from 0 to L of f of x dx, and a sub n is equal to 2 over L times the integral from 0 to L of f of x times cosine n pi over Lx dx. Similarly, we saw that if f is odd, then the Fourier series on negative LL is capital F of x is equal to the sum from n equals 1 to infinity of b sub n times sine of n pi over Lx, where b sub n is equal to 2 over L times the integral from 0 to L of f of x times sine of n pi over Lx dx. So we are going to go ahead and start off by finding the Fourier series for f of x equals x over the interval -3, 3. So f of x equals x. This is an odd function. It's a polynomial where the terms only are odd degree. And we have that L is equal to 3. So we are looking at capital F of x is equal to the sum from n equals 1 to infinity of b sub n times sine of n pi over L. So in this case, n pi over 3 times x. And our b sub n is equal to 2 over L. So 2 over 3 times the definite integral from 0 to L. So definite integral from 0 to 3 of f of x, which is just x, times sine of n pi over L, in this case again is 3x dx. So if we do our rapid repeated integration by parts, we have our u is x, our dv is sine of n pi over 3x. Differentiating down the left-hand side, we go x dot goes to 1, goes to 0. Integrating on the right-hand side, we will have a -3 over n pi times cosine of n pi over 3x. Then we would have a -3 over n pi, that entire fraction squared, sine n pi over 3x. Multiplying on the diagonals, take the positive product for the first diagonal, negative product for the second diagonal. we wind up getting that our b sub n is equal to, we have 2/3 times, that integral becomes a negative 3 over n pi times x times cosine of n pi over 3x. Then we are going to subtract off a negative, so we add 3 over n pi, that entire fraction squared, times sine of n pi over 3x. And we are evaluating this at 0 and 3. Plugging in 3, we have a 2/3 times, we would have a negative 9 over n pi times cosine of n pi, then plus a 3 over n pi entire fraction squared times sine of n pi. From that, we are then subtracting off what we get when we plug in 0. So we will subtract off 2/3 times. We will have 0 for the first piece, since we have a negative 3x, and then plus 3 over n pi, that entire fraction squared, sine of 0. So we have the only non-zero term is that cosine n pi term. All the others go to 0. So we are looking at 2/3 times negative 9 over n pi times cosine of n pi. This becomes a negative 6 over n pi times negative 1 raised to the nth. Again, cosine of n pi is just negative 1 to the n when n is an integer. Or in other words, we have our b sub n's are 6 over, or a negative 1 to the n plus 1. Times 6 over n pi. So these are our b sub n's. And so we have our series as capital F of x as the sum from n equals 1 to infinity of b sub n sine n pi over 3x, where b sub n is negative 1 to the n plus 1 times 6 over n pi. Next, we'll go ahead and find the Fourier series for f of x as the absolute value of x on negative 3, 3. So here, we are looking at an even function. Absolute value of x is symmetric about the y-axis. And then our L is again equal to 3. Since we are dealing with an even function, we know that our Fourier series is capital F of x is equal to a naught plus the sum from n equals 1 to infinity of a sub n times cosine n pi over, in this case, 3 x. So we take this format. We know that our a naught is equal to 1 over L, so 1 over 3, times the integral from 0 to L, or in this case, 0 to 3, of f of x, which is so absolute value of x dx. This is just 1/3 times the integral from 0 to 3 x dx. So we are looking at 1/3 times 1/2 x squared, evaluated at 0 and 3, or 1/6 times 9 minus 0. And we wind up getting that our A naught is 3/2. Beyond that, we go ahead and find our A sub n. A sub n is equal to 2 over L, so 2 over 3, times the definite interval from 0 to 3 of f of x, absolute value of x, times cosine n pi over 3x dx. This is the same thing as 2/3 times the definite interval from 0 to 3x cosine n pi over 3x dx. Again, running rapid repeated integration by parts, our u will be x, our dv will be our cosine n pi over 3x. Differentiating down the left-hand side, we'll go to 1 and then 0. Integrating down the right, we will have a 3 over n pi times sine n pi over 3x, followed by a negative 3 over n pi in parentheses squared cosine n pi over 3x. Multiplying on the diagonals, we will add the first product, subtract the second. So we have our A sub n is equal to 2/3 times, we will have a 3 over n pi times x times sine of n pi over 3x. And then we are subtracting a negative, so we will add on 3 over n pi, the entire fraction squared, times cosine n pi over 3x. Again, we are evaluating that at 0 and 3. This becomes A sub n is equal to 2/3 times, we would have a 9 over n pi times sine of n pi plus 3 over n pi, all things squared, times cosine of n pi. Then minus 2/3 times 0. Since we have a 3 over n pi x, plugging in 0 will give 0, plus, in parentheses, 3 over n pi squared times cosine of 0. So in this case, our sine of n pi also goes to 0. Cosine of n pi is -1 to the nth. Cosine of 0 is 1. So we are looking at 2/3 times 3 over n pi, whole fraction squared, times, in parentheses, -1 to the n minus 1. Or in other words, we will have a 6 over n squared pi squared times -1 to the n minus 1. Note that this is equal to 0 if n is even, and this is equal to 6 over n pi squared times -2, or a -12 over n squared pi squared if n is odd. So this is our A sub n's. we could summarize this. We get that our f of x is equal to our a sub 0 was 3/2. Then we have plus to get all of the odds from 1 on. We'll go from n equals 1 to infinity. And we will do 2n minus 1 now. So we'll have a negative 12 over 2n minus 1 squared pi squared times cosine n pi over 3x. Sorry, that n should be a 2n minus 1, not an n. So cosine of 2n minus 1 pi over 3x. So this is how we can go about finding Fourier series for even and odd functions.